Yes. So yeah, use it for mostly for ethical reasons, whatever we teach, and you're good to go. So as I said, like you mostly so far we have networking. So we have fundamentals idea of IP address, example MAC. You have idea of routing. You have subnets. You have network firewalls. Let's say firewalls, ports. Maybe you have some tools like Nmap, Wireshark, etc., etc. Maybe you have some models like TCP/IP, etc. Whatever. So mostly these are good enough to do to go into the cybersecurity domain deeply. Well, today onwards, we'll do mostly ethical hacking module. So we can think like attacking module, attacking phase, or attacking module. That's it. So I'll give you a brief idea about what ethical hacking is. Then I'll tell you the idea what we're going to do like today onwards. So I'll just so the idea of hacking. I mean, obviously, hacking sounds like generally it's a cool thing. Like you try to break in someone's uh, someone's portal, someone's door. The idea of hack is that you try to break in someone's door. The idea of ethical is more like a good reasons, like ethical in the sense like uh, for good reasons. Example, let's say if you sit at like today at any city cyber police, let's say, so the cyber police every day receive, I think hundreds of complaints every day. So it depends on the city to the city, but so usually any city you go, you take a look at it. Every day they get like thousands of complaints or hundreds of complaints, depends on the city or region. So most of the things are like that only. Hey, my money is gone, or somebody is kind of scamming me, asking for money, or asking, they stole my credentials, they share my photos, videos, extortion, this, that, like. So mostly all cybercrime in a way. So for example, now you are a police, let's say cyber police, I mean technical cyber police, let's say. Now you can have some good reason to try and attack the thief, maybe. So that we can call a good reason. The another good reason is, let's say I have a company, I'm building a website or some web app, something, or mobile app, web app, whatever. Now I want to have a strong security on that. So what I do, I will hire you as ethical hacker, whatever you call it. Then I will hire you, I'll give permissions to attack my uh, website or mobile app, whatever, my app. So I give you full permission. Hey, just try to attack it if you can. So if you succeed, then I fail. If you fail, I succeed. It's a zero-sum game. Obviously, I want you to two things. Let's say if you really attack, which means I fail. I fail to build. I fail to build good app, secure app. Let's say. If you fail, I succeed. I succeed at building a good app. So if you really attack and if you're really successful, then obviously there is a problem in my app security. So what I do, since I hire you, obviously I will fix the errors. I will make the whatever you breached, I just fix it. In a way, my app will be more stronger because I hired you as an attacker. If you really fail, that means my app is really good. So I'm more confident now. So maybe these are the reasons you can have an ethical hacker for industry or any industry, any software, not only web app. I can build an AI app. I can build a game app. I can build a cloud networking thing. I can build firewalls. It doesn't matter what I build. Even I can build a simple electronic devices. Let's say I can build a smart fridges. So obviously I want to make sure the smart fridge works well, no breach security. So I can hire you as ethical hacker to find the vulnerabilities in that for each exam. So it doesn't matter what I do. I will hire you as an ethical hacker. I give you full permission. Your job is to break in and try to find vulnerabilities or breach the security and stuff like that. Right. So I'll give you overview of the entire field so you can get better idea what to do. The first thing is like just think about it. Like what type of uh, attacks I can do. Just think about it. Look at yourself, like just like your computer screen. Now, let's say you can do few things. You can start. First is you most probably likely connected to your Wi-Fi. Example, I'm just assuming like you can think of like, hey, attack on Wi-Fi. You can do. You can attack on Wi-Fi, which means, of course, obviously you know your username and password. But imagine that you are like you are in physical space. If you look around, you want to attack something, you most probably find Wi-Fi is very common thing, right? So you have to know what's Wi-Fi attack, how Wi-Fi functions, how data transfers from Wi-Fi router to your computer. So which is again networking part. We already know a bit, but still you need to know Wi-Fi, how Wi-Fi security works mostly. So that is where we have to learn. The first task is Wi-Fi security. We'll have to go how Wi-Fi security works and try to break in and see if you can you know make sense. Like so that's the first probably class or topic or project or something like that, like we can say. Then the second thing, second common thing you typically do is like mostly password cracking. Again, this is very general because password could be anything. But in a way, I'll just put it as a general only. Uh, so password cracking more like, hey, let's see if I give you a piece of code, something like this. Example, name. If I give you a string like this, and I tell you that, hey, there is a message inside this string. Can you try to find the message? Like, anyway, it's not necessarily password cracking. It's more like a decoding information from the encoded things. Password is one of them. Usually, password is encoded. You have to decode it, but you can do a lot more things encoding and decoding. So I can call password cracking or hash cracking, but what I say is more like encoding information and decoding. That's it. Fundamentally is that one. Either you encode information, you decode. You can encode password, you can encode image, you can encode PDF file, you can encode anything. So you can encode any information. Your job is an attacker to decode it. Like as an attacker, you decode it. As a defender, you encode it. Like so, there are two sides. So that's probably our next topic or model we can say. I mean, next thing you can attack. And third is typically like we can say more like a login forms or uh, let's say uh, maybe not login, database attacks. So database attacks as an, for example, you log into the Instagram example. So obviously the first page you see is the login page. So obviously, of course, if you're in a ethical hacking mode, you want to crack like Instagram, you typically look at in login page, you try to bypass that in a way, like bypass mostly. So that considered as in a way database attack mode. So that's one. Similarly, any login page usually bypass only. You want to bypass the login page. So there are several techniques for it. So they can call something like SQL injection, they call. It's a technique to bypass the login page. Works or not works depends on the how secure it is. Similarly, there is no SQL injection, something like that. So or DB injection. Yeah, different names are there. So maybe these attacks mostly hack the kind of databases. So that's one. Then we have more like a web app attacks, web application attacks. So which is more like this. For example, if we go to our app, uh, okay. So this is a web app in the sense web application, which means it has some login page. You have to log in with, right credentials, like let's say, example, sorry. So I logged in, I see some things. This is application we can call it, web application, let's say. So now you can do some attacks, web application attacks. A simple attack would be like, let's say, you can attack session hijacking, let's say. Maybe let's say you can attack my browser or my web on this website. So you will know what I'm doing on this website. I mean, at least some information, not all, but some. So that you can call a session hijacking, like you typically hijack say. Or you can steal cookies, maybe. So every website is, if you know that, it's cookies. Every website usually they store some cookies for making their products better. So you either steal cookies. If you look at cookies on this website, uh, maybe in applications, you will see some. Yeah, so these are some of the data. So if you know this, actually, I mean, since I know this website, so obviously I can tell. If somebody knows that, they can log in without anything. Again, this is open only. That's why I'm openly sharing. This is open credentials. But yeah, so this is some cookie data. So we set some cookies. If somebody can steal these cookies, then obviously they can log in. They can do all things without, stuff like that. Similarly, you can steal any cookie, but an example I'm just showing. So that's one. Maybe you can inject some scripts, scripts, vulnerable scripts, let's say, malware scripts, let's say, which means, let's say I inject some script in this website. Now the script will do everything, not you. So for example, obviously this is a education website. There is nothing much to gain. But imagine this is some sort of financial website where I have to make a purchase of something. Then obviously they inject some, some code, let's say JS code. They can steal some information or they can steal your credit card data, etc., etc. I mean, whatever they can. So that's another probably attack. Uh, Similarly, I can say DDoS attack. So meaning like, so right now, let's say if I refresh it, so I make a request to this website. If I refresh 2 times, I make 2 times. If I refresh 3 times, 3 times, 4, 5, 6, 7, 8. You see, I'm getting an error. Again, we created a website like that, right? You can see 5, 6 times I'm doing it. I'm getting some error. You see. So the reason we did it, of course, we had a strong defense in the background. If somebody is requesting this page like many times per second, we will stop that. But that's a defense part, not attack part. But attack part is more like I request this page thousands of times per second. Example. Right now it's manual. Obviously, I can code this. I can make this request like 100 times per second. Example. So that's like a huge amount of data. That's what they call DOS attack, denial of service. DOS means denial of service. So meaning that think of it like more traffic. More traffic. Imagine you're on a road, you have more traffic. example, or some things happening, some event is happening, or some protest is happening, something. You are actual user, but you're not able to make it because the traffic is jammed. So obviously that is an attack, because if somebody is attacking 100 times, the actual user might face some problem. So of course, I have strong defense, obviously, but if the defense is weak, obviously the system will not be useful. So you can say it's error. So that's a defense part, not attack part. So attack part is I can send thousands of requests, hundreds of requests, thousands of requests, depends on my hardware per second. So that's a device attack. Device means only one computer. So typically what they do is they block my IP, example. But imagine uh, thousands of computers are attacking thousands of times. So that's like DDoS attack. So DDoS means distributed DOS, or distributed denial of service. Which is from many computers or many IPs, let's say, technical. Now this is more like you have multiple IPs, multiple computers, and multiple times per second. If somebody is accessing my website from one computer, maybe I can block them, I can give them some warnings or something. But imagine thousands of people are doing it. It's like a bot. No, I cannot block all thousands of people, because maybe they are real people, because we don't know. Because thousands of people from thousands of locations, it's very hard for me to stop it. Like, so that's more like a DDoS attack. Again, you still it works. We have a strong defense, but still, as attacking, we are discussing, so you can attack somebody with thousands of requests from thousands of computers if you can make it work. Yeah, so something like this. These attacks are very common. Uh, you can even make API attacks. API attacks. So API means you probably don't know. For example, every website you visit, let's say if I visit Instagram, example, if I inspect it, I go to network tab. If I make some, I don't know, something. If I enter login, it will make a API request. So when I click on login, let me click login. You can see. So this is what we call API. It will request this URL. Hey, I'm trying to log in with the data, username and password. You can see username is so and so. Password, of course, it cannot show. And you get a response saying that invalid credential, you can see user invalid. So that's where you get some. So this is what they call API. You can attack on this API. You can send requests, sending some wrong usernames, password, or try brute force. You will have to see whether you get like good, bad, is the authentication false, status okay, user true. See? So this is like more like API attack. So that's one of attacks. What else you can have? Mostly is that only web application attacks. Yeah, mostly is that only. Like I don't see, maybe one or two miscellaneous would be there, but I think we should know these minimum. So then, of course, we have mobile app. That's also very similar. Uh, Mobile app attacks. Example, if you're Android, I can send you like malicious code, APK, let's say, we call APK file. Now, if you install this file, then obviously I can track your mobile apps usage, and I can track your data mostly. Maybe you can access permissions like camera, phone, camera permission, speed, microphone. Uh, so I can listen to you, I can see you. Again, if you're a guy, maybe not a problem. But if you're a woman, obviously you'll have to careful. You have to be careful on that. Right? Yeah, mobile app attacks also very similar only, but you have to inject something. So that's one. Again, we'll focus less actually. We can only focus on Android. Depends on your interest. So that's another attack. What else we can try? The next one is network attacks. Yeah, this is what company mostly look for. So far, what you have done is these are independent attacks. I mean, independent application attacks in a way. But if you look at network attacks, there's more like, let's say, example, breaching firewall. You go try to breach somebody's firewall, maybe. So that's a network attack. That's a big thing for companies mostly like it. That's network. Maybe you can say uh, hack some servers. So in network means like a bunch of computers. One is server maybe, or a couple of them server. So you can try to access these servers and with maybe bypassing the credentials, whatever you do, and you can steal their data, etc., etc. Like, so that's more like a network attacks. You can have a lot more attacks actually. For example, again, I cannot name all of them. There's a general version of on it. Uh, you have firewalls, you have servers, then you have middleman attacks. Middleman attacks, like they call man in the middle, uh, man in the middle, something like that. So you can secretly see the data, what's going on between client and server in a way. Yeah. So you're just sitting there in the middle, like you're observing what traffic is coming, what's sending, what's receiving, etc., etc. You may not do any attack, but you're still sniffing, which means you're seeing the data. Like in a way, it's not an attack, but still you're breaching. I mean, you breach their network or something. So there could be many middleman attacks. Depends on the network, depends on the app. So yeah, these are some of them mostly. Uh, then we have very basic attacks, which is like what do you call like payload attacks. So this is again very difficult to do because you have to do some sort of psychology. Like for example, we call like social engineering. So social engineering in attempts, like for example, let's say, like I know you, you're my friend. Example. So I give you a small file or small image, PNG image. Example. Uh, you just opened it. That's it, done. So I can steal some data from your computer. I mean, I can even get full access of your computer because the payload, some payload means some data, some hacking, some script is there. That script is there on this particular file I gave you. I said it's a PNG image, but it's actually not a PNG image. It's mostly like a executable file I call. But in Windows computers, what it does, it ignores that executable file part. So users usually get confused, like, is it a PNG or is it a script? It's very hard to tell. So then you accidentally might click and your data might be gone. Similarly, I can send you a email, phishing email. We call phishing attacks. It's a phishing email. I send you like, hey, you are one crore rupees. Please fill this form or please click this link to, get the money, whatever. Like, so obviously you would be very interested. Like, hey, I won 1 crore. Like, it's like, hey, good thing. It's a bait. So it's some sort of social engineering is like that one. So most of the attacks nowadays are social engineering only for vulnerable people. Uh, Even you might get some bank calls if you have received like, hey, we are talking from so and so bank, your account is free, like we have frozen your account, we need to unlock your account within 24 hours, please provide us some your information so that we can unlock. So they create some sort of urgency or emergency. Then they try to steal data or whatever from you. So these are morely social engineering attack, and where they require some payload to inject you, and you give some data. Most of the attacks like that only. Or you can say some device attacks also. Device attacks. Example, uh, let's say device attacks. Maybe you have a USB or charging, let's say charger. Let's say you have some C-type charger, whatever that is, doesn't matter. Somebody created a device which looks like a charger, but there is a small script inside the charger. You may not believe it. It's a charger. Hey, I'll just charge my phone. That's it. But when you connect it, the script will get enabled. Your data might be, with the hackers. So that's a simple charger. It could be USB also. It could be some file also. It doesn't matter. It could be like a keychain, like car keys. It could be like remote. Again, whatever depends on the device to device. You can make any device. It looks like a real device, but inside you can have a script or some hardware thing where you connect to your computer. Everything is very much gone. Right. Data is possible. So unfortunately, we can't do these things at this time as part of our thing, but we will try to find some devices which we can acquire legally or for educational purposes. It's not a good reason to create these things legally, but going forward, maybe I'll try to figure out a way to get these devices legally so we can try and test things. But as part of our current curriculum, I don't think we can do it anytime soon. But when we get chance, we'll call you back and we'll see. Again, this comes also payload attacks only because you're using some sort of script inside all of these. That's a payload. What else? I think most of them we covered. Mm, uh, yeah, most of them we covered. Anything else is there? Right. Yeah, any questions meanwhile, just let me know. Cloud attacks and stuff we can try. Again, IoT, not sure we can try. But there are some platforms maybe I've recommended, like TryAcme or Acti. They provide some sort of a simulation. So I can maybe try to help you how to do it. But these are self-module only, I can say. You don't need guidance from me, but I'll give you high-level guidance of what to do. Like example, TryAcme is let's say platform where you can get some virtual machine, a simulation of an attack. So you can try to learn some things from there. Uh, Again, I'll take the main core idea, but simulation and everything they might provide, like it's better to use them. But other than that, like mostly we know it, like uh, the max you could do this only. If you can be able to do all of them, but not on like real, but simulation only. In real, some things might work, some things may not work. Doesn't matter. So hacking is not about like really working. It's about finding the loophole only. Because if it's really attacking, then why we don't have all these systems built? So don't think like every attack works in real life. It doesn't usually work most of the time. But what it does is it gives you some idea or vulnerability, and that is what companies want. They don't want you to attack completely. but they want you see which data is out or attackers can see. If you can find that, you're already a good hacker in a way. You don't need to really attack them. If you really attack them, that becomes more like a legally, you have to do it. Uh, yeah, it's something like this. Think of like a hacking is more like you're walking on the road, you're attacking some stranger. Generally, do you do that? You don't do that. You mind your own business. You just walk around. But if somebody attacks you while you're walking on the road, do you still feel like, okay, I'll just stand there? No, you will also attack back. You will also say, okay, you are attacking me, I'll also attack you back. So in those cases, maybe you are allowed to attack, but obviously when normal cases, most of the time, you just mind your own business. You just walk around the street without attacking anybody. So the main goal of ethical hacker is that only, not like really attack somebody or attack system, but if somebody is coming to your foot, then they try to attack you, then obviously you have no choice to defend first, attack them later. But your job is not like, hey, I'll go attack this person, I'll go attack you. That is not your job at all. Like even companies also, like you will not do that. You will mostly do maybe testing some internal things. That's true. But if somebody comes, you defend first. After defense, you can maybe attack to get back your data or whatever you have. But there's still some legal laws, compliance apply. You cannot be attacking even the attacker also in a way. So I just have to tell you the laws. The laws also depends on the country to country, but most of the laws are very much same only, general laws. You can see permission is mandatory. You cannot, but again, you cannot ask permission an attacker. Of course, attacker does not give permission. So those are some of the gray areas. Uh, yeah, so these are maybe these are international laws. First, you do virtual missions, test labs. Example, you do these things. Never attempt to real world attacks on websites without permission. Again, even if it's an attacker, still. See, rule of thumb: if it is not yours, you don't have permission, don't touch it. So that's the good way to be safe legally. Like, uh, let's say country by country. Let's say India and US mostly. Since I'm aware of mostly India and US, I can see India and US maybe. India, you have IT Act 20. US, you have like Computer Fraud and Abuse Act. Yeah, mostly these two you should know. That's it. UK also big area. Australia, Canada.